Hello everyone. In today's video, we will be discussing the basics of the probability. We're just going to touch over the basics, and this is the part one of the video. Another part will be uploaded in which probability is looked further in detail with Venn diagrams as well, with tree diagrams and other kinds of probabilities, right? So let's start. Okay. So for not only for AS and A-level mathematics, basically, the heading says so, but even for igcse, GCSE, or with any board you're doing probability, you need to understand this. There are certain definitions which are required to be understood, right? So one thing, an experiment. The question would always refer to an experiment, and an experiment is a repeatable activity, right? And the results of that experiment is the thing which is being observed or be recorded, right? And for that, we're finding the probability. For example, tossing a coin is the experiment. And if the coin is landing on a heads or a tails, that is being recorded or observed, right? So outcome, where the coin lands, that will be the result of the experiment. And all the possible outcomes can be shown in a sample space. Now, if we are just talking about flipping one coin, then there are only two possible outcomes. Either you'll get a heads or you'll get a tail, right? So there can be a very broad list, a very big one, right? Because you need to list down all the possible outcomes. Right? So that's not possible to just do it in your head when there are multiple outcomes, right? Here in the example I gave you about tossing a coin, there are only two outcomes. That's easy. But once there are more outcomes, you can see over here, there in this diagram, right on your video, there's a sample space for two four-sided spinners, right? So, and the outcome is basically the product of the results of both the spinners, right? So if you get a -1 and a -3, it's a 3. If you get a 0 and a -3, it's 0. If you get a 1 and -3, it's -3. If you get a 2 and a -3, it's -6, right? And so on and so forth, right? That is how you're getting the outcomes, right? So in this case, since there are four, it's a four-sided prism, two prisms product, we are actually getting 16 outcomes, right? Now, an event is basically an outcome of, or a collection of outcomes, right? And that is what we're interested in. We're interested in what outcome we are going to get, right? There can be more than one outcomes. For this spinner, right, the event, the product is -2, they have one outcome, but the event that the product is negative, there are 6 outcomes. So here you should differentiate between what an event is and what an outcome is, right? Outcome is all the outcomes. There are 16 outcomes for this particular sample space. Each sample space, each part of the sample space is one outcome. But in the case of an event, you can have events in different ways. Event of getting a positive number, event of getting an odd number, event of getting an even number. And there can be multiple outcomes relating to one event. There can be one outcome, there can be no outcomes, right? And there can be multiple outcomes. Now in probability, this was all the basics, right? You're also supposed to know about 3 things, that is intersection, union, and complement, right? We're going to do these definitions in the level 2 video, but here what you need to understand is not and or. And means both the events, A and B, will happen at the same time. Now, in that case, the probability, in case of a probability, you should multiply the probabilities of the event A and the event B to get the total probability. Because the experiment suggests that both the events can happen at the same time, A or B, right? That means that event happens, either A event happens or B event happens, or both can even happen, right? And that you will have to add. You'll have to add the probability of event A with the probability of event B to get the total probability. And not A means that the event does not happen. So probability of not A will obviously, since you know the total probability is 1, so if I ask you what is the probability of not A? No, okay, let's take an example here, right? Let's go with an example. Let's say that I have a 3-sided spinner with number 1, 2, and 3. I ask, it's a fair spinner. That means each of them is equally likely to happen. That means one event has a probability of 1/3, 2 has a probability of 1/3, and 3 also has a probability of 1/3. Now, if I tell you that probability of you need to tell me the probability of 1. It's simple. It's 1/3, right? If I tell you, you need to tell me the probability of 1 and 3. At that time, you're going to do 1/3 multiplied by 1/3. If I tell you, you need to tell me the probability of 1 or 3, then you're going to do 1/3 plus 1/3. That's the difference between the and or, right? And logically also you can see. But if I tell you, you need to tell me the probability of not getting a 1. Now, one way you can do that is you add the probability of 2 and 3. Either you get a 2 or you get a 3. These are the two situations in which you won't get a 1, right? But then other possibility would be you find the probability of not 1, right? And that would be 1 minus probability of 1. Right? Because the total probability is 1. So what you do is you do 1 minus 1/3 and you give me the answer that, okay, that is 2/3, right? Which is correct. But what I'm trying to explain you, that is the meaning of not A. So probability of not A is always 1 minus the probability of A. Because obviously, if the probability of event A happening is 0.6, the probability of event A not happening would be 0.4. Because the total probability is 1. Right? Now, probability of x is less than equal to 4. Here it's written as 0.4. So probability of x is greater than 0.4 would be 0.6, right? Greater than 4 would be 0.6. Apologies. Okay. So these are the basics. Now let's move further. Probability of success of anything, of an event, you know, that is number of ways, the number of outcomes you can get that event upon the total number of outcomes, right? We also discussed probability of not A is equal to 1 minus the probability of A. That is, we use the word complement for that, okay? All right. Okay, so basically, you need to talk about other things in your experiment as well. For example, the outcome from rolling a fair dice have theoretical probabilities, but the outcome from a football match would be based on previous results between the two teams, right? For a dice or for a coin, you can use theoretical probabilities. They are equally likely, you know, basically for a fair dice or for a fair coin, there is equally likely of getting a heads or a tails, or there is equal possibility of getting numbers from 1 to 6. But it is not the case in all the things, right? If you want to get an outcome of a football match, you do not have theoretical probabilities in that case, right? What you only have is the previous result between the two teams. That can be big. So there can be biases in the experiment, and you need to be aware about them, because that is how the theory part can be tested. They can test you on that, right? So that is something you should spot then and there. Okay. Then, according to exam point of view, you need to understand the common ways of displaying the data. Right? Okay. Now, we have understood the topic of probability, right? And let's try to figure this out. Find the probability. The histogram below shows the distribution masses in grams of 80 newly hatched ducklings. Find the probability that a duckling chosen at random has a mass less than 54 grams. Now, when you are looking at less than 54 grams, let me bring you here. You're actually looking at this whole part. So you would want to take the probability of all of this, right? From 46 to 50, right? So what do? It's quite simple here. You need to add the probabilities. Either it can be, 46 to 50, 50 to 52, 52 to 54. All three are open. So either it can be one of them. You'll add all the probabilities. The total outcome is 80, right? 80, that's where you get it from. This is frequency density. So the frequency density into class width will give you the frequency. So 4 into 4, 16, 2 into 8, and then 2 into 12. That's how you get a probability of 0.7. Very simple. Finding frequencies above 53 grams, right? Duckling chosen at random as a mass greater than 53. Now, this is this part, right? So what do? This time you're taking 2 into 12, but you'll have to. Or what you can do is you can do 1 into 12 because the frequency, the class width is 54 minus 53, right? So 2 into 12 divided by 2 plus 2 into 10 plus 2 into 2. You do that and then you'll get the product. You're again adding because this is an OR situation, right? So this was the basic probability video, and we will move further in part 2 to see the further probability. Thank you.